All right, so most kids will probably leave these blank. Most kids will leave blank. General exponential model, f of x, or whatever you want to call it, is a b to the x. Compound interest formula is going to be that the amount after time passes is the principal times 1 plus r over n with an exponent of nt. The formula for exponential growth, the amount after time passes, is the principal times 1 plus the rate of growth raised to the t. Exponential decay, the amount after time passes, is the principal times 1 minus r to the t. Continuously compounded interest is the one that most kids have good luck remembering, is simply PERT. The principal times e raised to the rt. Ta-da! All right, the exponential models below are the annual rate of increase. Find the monthly and quarterly. Looks like I have number 7 bolded. Now, the idea here is you can multiply any number by 1 and not change it. You can multiply anything by 1 and not change its value. A little trick in math that lets us manipulate the crap out of some stuff. So if I want to do monthly, let me write this out. There are 12 months in a year. All right. Hold on, be right there. Let's see here. Where was I? All right. So I got interrupted. You're supposed to find the monthly and quarterly rate. So there's 12 months in a year, and then there's also 4 quarters in a year. So now that's stuff for later. So here's why I'm saying you can multiply anything by 1. I've got an exponent of t there, and I'm going to multiply it by 4 over 4, because 4 over 4 is 1. And let me switch over to pencil here so I can write it properly, even though it'll look worse. So if I multiply t by 4, I have 4t, then I've got this over 4 there. I'm going to move this, by the way, this is 4t times 1/4. I'm going to move that 1/4 in. All right, so I move the quarter in. Now I don't know the 4th root of 1.055. I don't. But I'm going to take that and I'm going to rooftop it to the 1/4 power. And I'm going to write down 4 digits of that number, 1.0135. 1.0135. Now, if you think about your exponential growth models, this right here, this 1.0135 is equal to 1 plus r, because notice the line up. Subtract the 1, and your monthly, I got the percentage sign in the wrong place, but whatever, r is 1.35% per month. Sorry, that's per quarter. I don't know why I did the quarter first. All right, that's per quarter. Now I'm going to do the same thing here for the monthly. And, none of this is actually needed. But this time I got 1.055, and it's to the t, and I'm going to multiply it by 12 over 12. I'm going to move the 1/12 inside. Now the outside is now 12t. T is still in years. I'm going to go to my wonderful little TI-84. Rooftop that to the 12th power, the 1/12th power, sorry. And I get that decimal, 1.0048. And again, I line 1.0048 up with 1 plus r. And I do some subtraction, and r is 0.0048 or 0.48% per month. Kids are horrible at this. The EOC, however, wants to know how well you can manipulate models. It is what it is. Sorry about your bad luck. Let's see, 9. We are taking $2,400. We're going to invest it at 5.25% interest, compounded semi-annually for 20 years. So to do 9, I have to use the compound interest formula. Principal times 1 plus r over n to the nt. This is going to be 0.0525. I could probably name the 25 juniors who don't understand how to move that over, but whatever. Got to convert that to a decimal. I've got 2,400. And by the way, it's the amount after time passes. Is 2,400. 1 plus 0.0525. Semi-annually, 2. Raised to the nt, n was 2. And the time is 20. Now, there's some things you should do in a calculator. Like, you should know what 2 times 20 is. You should. Doesn't mean you do, but you should. So there's the 1 plus r over n, roof-topped to the nt. If you don't know what 2 times 20 is, God bless you in the first place, but whatever. Ta-da! Your calculator can do it for you. $6,766.09. Took 20 years, but you more than doubled your money. 676609. The reason I went out 2 decimal places is because it's freaking money. 11 is compounding continuously, so your formula here is going to be PERT, P times E raised to the RT. Oh, let's do time of 30 years. A lot of these are missing times, aren't they? I need to go back and put some times in here. 0.04, 30. I need to be doing some, no, the time is there. That one's got a time. This one doesn't. We'll do that one for 30 years. I don't even have to fix that since I'm doing it with you. We got 16 grand. 1, 2, 3. There's an E key, second natural log. 0.04 times 30. If you don't know, that's going to be like 1.2. Calculator will do it for you. $53,121.87. $53,121.87. Not bad. Too bad it took 30 years. All right, write an exponential model between the 2 given points. So we're going to use this form, y equals ab to the x. What we're going to do is we're going to plug in. We're going to write 2 different equations. We have 85 when x is 6. Make that b uppercase. Otherwise, it's going to look like a 6 itself. And we have 92 equals ab to the 7th. This isn't going to be pretty, is it? what I'm going to do is I'm going to divide both sides here by b to the sixth, because that's going to give me an a value. A is 85 over b to the sixth. Now I can put that right there. 92 equals 85 over b to the sixth times b to the seventh. You guys have been taught your rules of exponents. B to the seventh over b to the sixth is b. 92 equals 85 b. So b is 92 over 85, a not so pretty number. So let's go back to the original equation here. I now have b. B is 92 over 85. All right. And now that I know what b is, I can actually solve for a. I'll probably need a calculator for this, but I'm going to take this content and I'm going to put it right there. A is going to be 85 over 92 over 85 to the sixth power. And boy, it's going to be hideous, isn't it? Like, wow, that's going to be hideous. Most of these things are. Now, I am not capable of doing that in my head. I have an 85 is divided by 92 over 85 to the sixth power. It's kind of an ugly decimal. Keep 4 decimal places. Or let's see. Math, enter, enter. Yeah, 52.8695. 2.8695. 56.8295. And I wrote that wrong. This was messed up. There we go, that's better. So, final equation. I got a fraction to start off with. That was kind of nice. And I got this ugly decimal. And I'm sorry you have to learn this. State of Tennessee requires that all kids take Algebra 2. Sorry about your luck. All right, here we have a calculator problem. So here's what I'm going to do. I'm going to put the time into list 1, temp into list 2. I'm then going to hit, by the way, I do that by going to stats edit. I forgot to say that first, stat edit. Then I'm going to quit. And I'm going to press stat edit. I'm going to scroll on down to exponential regression. Blah, 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 hit calculate. That's how I'm going to do this problem. And actually, I'm going to pause this so I can go take attendance into enrollment in just a minute. All right, so I've got my data in. I'm going to hit second quit, stat, calc. I got to scroll down to exponential regression. There she is. Click on your barcode, makes things a lot easier. Scroll on down to calculate. Notice how I've got everything here. I've got an X list, list 1, Y list, list 2. There's no frequency list. I'm not going to mess with storing the regression equation. Enter. And here's my little equation. Also, ethics bowl practice, the today during directed studies and after school. Parent teacher conference will be Thursday, 3 to 6, so we'll have no after school scholars. Thursday, we'll resume that again next week. Now, why did I write that equation? So I can figure out when she's going to serve it. She is going to serve her pizza when it hits 150 degrees. So 150 is going to equal this equation, 329.7952 times 0.9726 to the x. That's what I got to type in. And I'm going to do the whole y1, y2 thingamajigger when I get back. I need to break for a second. So pause this. All right, so I'm back again. So y equals this thing. Actually, I'm going to do something a little different. I'm going to go to stat calc. I'm going to rerun through this process. That was an exponential regression. And if you're playing along, you'll like this. If you're not playing along, well, you know, it is what it is. I'm going to scroll down where it says store regression equation. And I'm going to hit the vars key. Scroll to y variables. Function is what I want. And I'm going to put that in y1. Now I'm going to scroll down to calculate. This screen looks exactly the way it should. But when I go to y equals, there is the regression equation. It's in y1. Now, what was the goal of this text? She's going to serve it at 150. So I'm going to put 150 in y2. I'm going to do my zoom 6 like I've always done. I'm going to hit window once my calculator quits working. And it's just a spinning and spinning and spinning there. Window. I'm going to adjust my y max to 200. And I'm going to go out for 30 minutes. Maybe that's enough time. 30. Then I'm going to hit graph. I should start seeing something get graphed pretty soon. 30 minutes did it. There is my intersection. Second, trace, 5 for intersect. Some kids ask me why I use the buttons. I use the buttons to slow down so that you can see what I'm doing. I'm going to take my little cursor. I'm going to get her close, and I'm just holding that arrow till the cursor shows up. And there she is. I get close. I press enter once, twice, thrice. 28.34 minutes is how long it takes to cool down. So, time to cool is about 28 minutes. So she took it out at 5. Must be 5:28, right? Makes sense. You know, you guys are going to have to show me some stuff. You have to show me the things you can. You can't just write down 5:28 on your piece of paper. You've got to show me the regression equations, things you came up with. Please play along in a calculator. All right, number 17. A certain rumor about you spreads around town at a rate of 300% every 4 hours. This has the word every. That's a big deal. Every 4 hours. Now, this is a rumor that grows, so I'm going to be using the formula for exponential growth. But again, that every is a big deal. When the word every shows up, you have to introduce fractional exponents. How many people currently know this rumor? One person knows the rumor. Principal's 1. 300%, that's pretty impressive. That's 3 as a decimal. The exponent becomes t over 4. All right. Rewrite part A so the equation now represents how fast the rumor spreads every hour. Right now, this is written every 4 hours. What we're going to do is we're going to move part of that exponent inside. By the way, ones are understood. 1 plus 3 is 4. And we're going to move that quarter inside, leaving a t on the outside. You just manipulate it a little bit. Part C, if there are 21,200 people in this town, how many hours until they all know? You can use either part A or part B. I'm just going to use part A. I want to know when this is true. The ones are understood. 1 plus 3 is 4. I actually don't need the parentheses on that. 21,200 equals 4 to the t. That's my equation. And I'm going to y1, y2 the whole thing. Left-hand side y1, right-hand side y2. It's not too hard of a problem. Of course, the issue is setup. It's the issue with most. The issue is getting kids to sit down and try, and I used to be good at that. I don't know if it's me or you. Getting a lot of flack back lately that kids hate math because of me, when I literally give you everything. Anyways, I scroll up to window. I'm sorry, I'm going to do a Zoom 6 first because that was previous window settings. I just want to clear the window. It's funny how that works. The more you give people, the more they complain. Anyways, the X max, I don't know. Let's take it out 100 hours. I think there was a 21,200 for the population, so let's put 23,000 or 22,000 in there. And hit graph. Oh, it didn't take long at all, did it? I hit second trace 5. I'm not even going to get close because there's only one answer. Enter, enter, enter. 7.1859 hours. 7.1859 hours. 7.1. Tired, forgive me. 859 hours. Now, if you tell somebody 7.1589 hours, they're going to be like, what? What is that? That's 7 hours. All right. I'm going to take that 0.1859. I'm going to multiply it by 60 because there's 60 minutes in an hour. 11 minutes. Now I'm going to take that little decimal 0.154 and I'm going to multiply it by 60 because there's 60 seconds in a minute. 9 seconds. Which is a big deal if you're talking about a rumor about you. But you have 7 hours, 11 minutes, 9 seconds until there's nobody in this town that likes you. Think about that. Wonder what the rumor was. 19, a typical student's attention span decreases roughly 15% for every 6 minutes in class. Write a model that describes the student's attention span. We are decreasing, therefore we are decaying. After time passes, we must be the principal times 1 minus r raised to the t. That's the idea. That's what we're plugging into. Now, the principal would be 1. The idea would be that I have 100% of your attention. Right? So that's 1. 1 minus 15%, 0.15, roof topped to the t over 6. Why the t over 6? because of that key wording in here, every 6. Now, I cleaned that up a little bit because I happen to know what 1 minus 1500ths is, and I happen to know that certain things in mathematics are understood. All right, there's your model. When will the student's attention span be 70% of what they started with, and it's not 12 minutes? Some kids think it's 12 minutes or whatever. But anyways, show the setup, use a calculator. 70% is going to be the decimal 0.7. 0.7 must equal 0.85 roofed-topped to the t over 6. That's the setup. And then you just use your TI-84. .7 in y1. We have 0.85 with an exponent of x over 6. Zoom 6 it. You should see that on a Zoom 6 window. You may not, but you should see it. Anyways, enter, 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 enter. Oh, no sign change. I have to zoom out. Anyways, let's go out 48 minutes because there's 48 minutes in a class at DHS. So I adjusted the X max to be 48 because that represents an entire class period. Second trace, back to 5, enter, 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 13.168 minutes. Which is going to be 13 minutes and some seconds. I'm going to take my 0.168 and multiply it by 60. The reason I'm doing this is because things like that don't make sense. I mean, we're taught time in minutes and seconds, 10 seconds. What percentage of a student's attention does a teacher have after 48 minutes of class? It's not much, and the truth is this model is extremely generous. But anyways, I changed the time to 48. That's all I do. And then I go push buttons on a calculator. About 27.25%. Which is very generous because I don't think I have 27.25% of your attention at any point in class. I don't. If I did, your grades would be better. They'd be a lot better. Last one in this video is a trig problem. So we have a geometry problem. This is straight up from geometry. It's not an Algebra 2 standard, it's geometry. It's an ACT standard. All right, so we have that the sine of theta is 4 over 5. The angle exists in quadrant 2, which I hope you know your quadrants. Your quadrants are labeled 1, 2, 3, 4. It's most kids' experience with Roman numerals right there. Anyways, we're in quadrant 2. So I'm going to draw a triangle in quadrant 2. I'm going to put theta right there at the origin. Interesting. Wrong letter. Still pick the wrong letter. I want theta. There we go. And I talk about the sine ratio. The sine is opposite over hypotenuse. So opposite is a 4, hypotenuse is a 5. And if I do a little Pythagorean theorem, I have some unknown side here. We'll just call it x. X squared plus 4 squared equals 5 squared. If I do 4 squared, that's 16. If I do 5 squared, that's 25. 25 minus 16, everybody knows is 9. So x has to be 3. Now, direction matters. You're running left on the x-axis here. That's negative 3. I'm not saying this triangle has lengths of negative 3. There was never a triangle there in the first place. There wasn't. But I ran left 3 units. I want to know the tangent ratio. Tangent of theta would have to be opposite over adjacent. Well, I keep picking the wrong Greek letters here. I'm clicking on that one. Now, if you're wondering how I know about this whole opposite over hypotenuse and opposite over adjacent, it's because I know SOHCAHTOA. That's how. So use that. Anyways, opposite over adjacent. You guys see what I'm saying? I'm literally touching the... I don't understand what's happening here. There we go. Opposite is a 4. Adjacent's a negative 3. So I have 4 over negative 3. Negative symbols belong in the numerator, not the denominator. Negative 4/3. And that, boys and girls, is your homework for 6.2.